Today we delve into autoencoders, unraveling its complexities and showcasing its powerful applications. Autoencoders, a special type of neural network, are designed to copy their input to their output. They work by compressing the input into a latent space representation and then reconstructing the output from this representation. This might seem like a simple copying task, but the real magic lies in the middle layer, the so-called bottleneck. An autoencoder consists of three main parts: the encoder, the bottleneck, and the decoder. The encoder compresses the input data, the bottleneck holds the compressed representation, and the decoder reconstructs the input data from the compressed form. The key here is that the autoencoder learns how to perform this task by itself. It's a self-learning algorithm. No specific rules are dictated to it. Next, we'll grasp the concepts of undercomplete autoencoders. These are the simplest types of autoencoders where the dimension of the latent space representation is less than the input data. This forces the autoencoder to learn the most salient features of the training data. In contrast to this, there are the overcomplete autoencoders. In this case, the dimension of the latent space is greater than the input data. This might lead to the autoencoder simply learning to copy the input to the output without learning any useful data representations. Applying autoencoders. They are widely used in anomaly detection, denoising data, and dimensionality reduction. They shine particularly in tasks where the input data is unlabeled. Implementing autoencoders. For this, we're going to use a Pascal-based example available at the link provided in the details below. The code is broken down into manageable chunks, making it easy for anyone to follow along, regardless of their programming background. In this Pascal-based example, we have an 8 layers encoder. This encoder encodes a tiny image with 64 by 64 RGB pixels into a 4 by 4 by 128 volume. The downsizing is achieved via the stride parameter. This is our bottleneck, 4 by 4 by 128 volume. Then comes the decoder. We have 8 layers expanding the bottleneck up to a 64 by 64 RGB pixels image. These are the output images generated by the autoencoder. As this is an undercomplete autoencoder, these images aren't perfect as the autoencoder preserves only the main characteristics of each image. Thank you for watching.